Yes, we are. Okay, quiet please. Okay, so inductive reasoning again was making a conclusion based on observations and patterns. Conjecture. Okay, conjecture is a concluding statement. Perfect. I'm in mid-season form right now. A concluding statement reached using inductive reasoning. Man. There we go. Okay, so you use inductive. So like if we look at number one, okay, we're going to use inductive reasoning to try and uncover what this pattern is, okay? What the next 5 terms in the sequence would be, okay? What are ways to do that don't necessarily have a surefire, like one way to do this?
See what they have in common.
Yeah, it's just trial and error, right? You're just looking at all the different numbers and trying to find relationships between them, okay? So if we look at 38, 31, 24, 17, okay, don't say anything out loud. Just kind of look at them for a second, okay? See if you can recognize any sort of pattern, okay? Can anybody tell me what they think the next number is, Oliver?
10.
Yeah, it'd be 10, okay? So our inductive reasoning is that what? Okay, so you are making the conclusion that this pattern is subtracting 7 every time. Okay, so can we fill out the rest of this? 3, -4, -11, -18. Okay, so conjecture, okay, is your concluding statement. Okay, so something to the effect of it wouldn't have to be, word for word like this. Okay, to generate the next term, you will subtract 7 from the previous term. Okay. A couple of those words in that statement are the ones that are very important. Okay. What exactly is happening? Okay. You're subtracting 7. Okay. And then where you are working off of. Okay. So it says subtract from the previous term. Previous term is the other super important aspect of this. Okay. Because you need to know that you're looking back at the one that you just created, okay, or generated, okay, or one right before. It won't always be that way. Sometimes you'll look all the way back at the beginning term, okay, or something like that. Rocco.
Would the next number in the pattern will always be 7 less than the one before the given answer?
Yes, I think so.
Do we have to write conjectures and fancy people writing?
No. No.
Why not?
But being a bougie math student is always great. Okay. Number 2. Okay. Let's try and recognize the pattern. Oliver.
So it's +3, but then it goes +6, and then it goes +12.
Yeah.
No,
So
you
you're
can just.
timing it by 2.
I disagree, bro.
Times 2 plus 1.
I agree with that. Times 2 plus 1.
Times 2 plus 1. Correct. So we would say, so Oliver, yours. I'm not sure it would work all the way through this pattern. It was a good one though. Okay. So 2, 5, 11, and 23. So what they're saying is, okay, if you look at 2 and you double it, that is 4, hopefully we would all say, and then you will add 1. Okay, so that's 5. 5, if you double it, that's 10, plus 1 is 11. Okay, so if you're filling out the rest of this, you'd have 47, 95, 191, 383, and 767. I did not expect any of you to have all of those right there. Okay. Mm-hmm. Just having it there so that you can fill out the rest of your pattern. Okay. What would the conjecture be?
Times 2 plus 4. Times the previous term. Plus what you do, and
Yeah,
add one
yeah.
to it and change that.
Double.
Good.
Yes.
Soren, how did you know? Okay, so to generate the next term, double the previous term and add 1. Okay. Let's go ahead and do. Yeah, let's just look at 3 together. Okay. So 3 together. Have we had a chance to look at it yet?
I got it. I said I got it.
Oh, and what'd you get?
For which one? 3.
The one you said got it on.
It's counting up by 2. And you're adding it every time. So the first one is plus 3, and then it's plus 5, then plus 7, then plus 9, then 11. So on and so forth.
Okay.
I labeled it as stacking addition plus 2 more each time.
I don't know how you say
You're
that.
stacking the addition. It's stacking addition. It sounds cool.
So let's just say you're not wrong with that particular pattern, but how would you write that as conjecture?
Stacking addition plus 2 more each time. Because you're stacking the addition together. Because plus 3, it gets 2 stacked onto it each time, and then it's 5, and then you stack 2 more onto it, it's 7.
Stacking is not a mathematical term that I am aware of.
I created it.
You have a different. Well, how would you word it, Mr. Gannett?
I would word it completely differently.
I'm gonna have to get it a
And
3.
how is it that you would word it?
How is it that I would word it?
Yeah.
How would that
So each term is a perfect square, so I would find the nth term squared. So 1, yeah, each 1, 4, 9, 16 are all perfect squares. So 25, 36, 49, 64, 81. Now,
Mr. Bennett, I'm gonna get a math degree just so I can have a term named after me. It's gonna be called stacking.
the Franklin stack.
It's gonna be called stacking addition, and it's gonna be what that
When it
is.
gets in a textbook, I'll get you to sign it for me.
So when you do stacking, you can say, you can just simplify by people and exceed.
Do what? No, it's that each. Okay, listen real quick. Listen real quick.
Did you say perfect square or square?
These are all perfect squares.
Oh, okay.
These are all perfect squares. So the patterns might not, the reason that I wanted to talk about this one is because the patterns might not always be what's happening in between the two. Sometimes it's what do these numbers have in relation to each other. Okay. Does that make sense?
Yeah. Yes.
We'll see. Okay, so for conjecture, like each term is a perfect square. Man. Okay, so to find the to the nth term, you will square n. Okay, so what do I mean? This is the first term. Okay, so if you square 1, what do you get? 1. Okay, this is the second term in the sequence. If we square 2, what do we get? This is the third number in the sequence. If you square 3, what do you get? 9. Okay, and it goes all the way down. Okay, so when it's talking about the nth term, it's not talking necessarily about like 36 in relation to 25, but it's talking about that this is the sixth term. So if you square 6, you get 36. That's the next number in the sequence. Okay, 4, 5, and 6. I would like for you to try those on your own.
Just write it down. I did it.
Once you figure out the pattern, be sure that you can get a conjecture down.
What if you have a nosebleed? Can't plug you.
Or you can just go off.
And if you come back on, you not.
When you die,
Yeah. Like if somebody had said about some time died, it was
well, you see, unless I'm playing other
That's why you have to hold yourself.
So if you to generate the next term for this, we're skipping over 2 letters. Would it be skipping over 2 or skipping over 3?
So you're skipping over 2, I would say.
That's what I was saying, because she says you're skipping over. Okay.
You're skipping 2 to get to the next one.
She's saying you skip 2. That's what she's saying. She's saying you skip 3 because you skip. No, she didn't say. She didn't say she was skipping 3. She was skipping 2.
That's interesting.
I'm skipping 3.
Yeah. You're skipping 2, the third letter away is what you're trying to say. Okay. But you are skipping 2 letters to land on the third.
You're skipping 2. So it doesn't sound like a real word. What do we say? Letters.
Okay. We're not done. I'm just asking a question. Has anybody gotten through 6?
I'm doing it.
Yes, I'm on 6.
Does anybody feel like they figured 6 out?
Yes. It goes 1. Wait.
Franklin, don't say stack.
Oh, okay, one goes 1, 6, 1, 7, and then 1.
For the following terms? Is that what you're saying?
Yeah. I don't know how to phrase that now.
I
Stacking
put go to
ones.
1 and then add 1.
No, I next turn.
Franklin, I'm going to help you.
Stacking plus 1.
Franklin, I'm going to help you get that math.
It's stacking plus 1 because you have to go to 1 and then go up.
I'm going to say no, Franklin.
Yes. Stacking mathematical.
Put it on the t-shirts.
Yeah.
How did you go? I
Mm-hmm. These are perfect. This one's not right, but I don't expect anybody to get that right. So we're going to talk about it in a second. Okay, I'm going to give you just a couple more minutes. Okay, then we're going to talk about these. If you are still working on those, keep working. We're going to talk about them. If you are done working on them and you would like to proceed, if you will flip over to the back page, I only want you to go through. Listen, please.
Listen.
I only want you to go through. Okay, these are true or false questions. You're only going to do the ones that are true. Don't mark anything on the ones that are false because I'm going to show you what I need you to do. Okay, but on 7 through 16, okay, just mark true on any of those statements that you believe are true. Okay, and we'll go back to it again. Another like minute or two. Okay, on 4, 5, and 6, and then we'll talk about it. Like 7 and 8, or 8 and 9. We'll see.
Really small, really big. You're like, she was really small.
What does it mean supplementary to the same angle?
So it's saying like if you had maybe 3 angles in a row, and 2 of those angles are supplementary to one single angle.
Oh. Me too. What did you just tell him? Because I need it as well. It's false. Okay, never mind.
The word? Yeah. Pen are like those things. Well, I probably call them all a pen. They are here. Okay, guys, if you will flip back over to that first side so that we can just talk about these. Okay, so some of you are able to find some patterns, okay? They might not always necessarily be the pattern that matches up with the one that I have. Okay, that won't necessarily mean that you're wrong. Okay, but we are doing reasoning and logic. Okay,
It does this a lot, guys, we know.
Yeah, but like, that's not good.
it's true. There we go. Okay, so let's look at number 4. So number 4, okay, your consecutive terms should have been M, P, S, V, Y. Okay. If anybody needs help with your alphabet, Miss Dobbins or Miss Riley, I'm sure can help you out. Okay.
I actually have to like say mine like out loud to get there.
No judgment here.
No one knows their alphabet.
What's that?
I know it. I can talk about my dyslexia. I got
Okay.
I can't tell you.
Okay. Conjecture. Okay. Would be to generate the next term, skip. Oh dear. Skip 2 letters. It was my master sword. 2 letters after the previous term. Okay, number 5. Okay, number 5. Obviously, we're working with some time. Okay, so our consecutive. Use the time step. Okay, 25 minutes. 10, 9:35, 10, and 10, 25. Okay. Conjecture would be to generate the next term, add 25 minutes to the previous term. Okay, so here's what I would like to do with you on number 6. I'm going to show you. Quiet, please. Okay, with number 6, I will show you the correct terms. You can check yourself, and if you did not get the correct terms, then you'll probably want to adjust your conjecture. Okay, so I will give you 2 minutes to see if you can fix number 6 for yourself.
It's 5. Oh, I'm so smart. I realized that. No,
It is.
I didn't know it. I knew it. What did I do? I had it. I did it because of 5.
I still don't know what the whole. I only know the first 3.
I used to know. I did it
For a contest.
You gotta find the answer to my
That sounds like the coolest, nerdiest contest I've ever
Yeah,
heard.
only 5 people did it. Me, Tyler, Karen, all the smart people. I just memorized it. Well, there was a song like.
Okay. So we heard the realization. So For those of you that did figure it out, thank you for not letting everyone else try and think about it.
No
But,
problem, Mr.
uh,
Bennett.
If you look at the pattern of numbers, okay, it's a number that should be pretty familiar to you. For some of you, maybe only the first three. Okay, 314, 1592653. So that is the consecutive.
I didn't know what
Not till March.
I like that.
Be careful, be careful, be careful.
You have a mic.
Okay, your conjecture should read something like each term is a digit of pi. To find the nth term, find the nth digit of pi. What?
Why is it?
N is a number. Just what we use for sequencing and math. Okay. The nth. Okay. So if you haven't finished working on those ones on the back, just go through them, but we are going to talk about them. So once you get this written, you can flip over there. I'll head over there in about 30 seconds. Okay, guys. Quiet, please. Okay, let's talk about these. I would love to finish these so that you could have time to work on your homework. Yeah, welcome back. Okay. The sum of two consecutive integers. Consecutive integers are what? Give me an example. Uno, dos. Yes. Okay. So the sum of any two integers. Is that sum always odd? Okay. Number 8. Quiet, please.
Number 8.
An integer is a whole number, positive or negative. Okay. Number 8. The product of two numbers is always larger than either number. Okay. So this is where we're going to go back up and look at our definition for counterexample. Okay. So a counterexample, okay, is an example that shows, that shows a conjecture is false. Okay, so all of these statements on this back page are conjectures. Some of the conjectures are true, some of them are false. If they are false, you must give a counterexample. Okay, the product of two numbers is always larger than either number. When does this come into play where that conjecture is not true? Okay, all of those, right? So if we did 2 times 1/2, that equals 1, right? If you do 5 times 0, that equals 0. Okay. If you did, so if we did 5 times a -1 equals -5. Okay. All of those are counter examples. You do not have to give on the rest of these or on your homework. You do not have to give all of the counter examples necessary. Okay, just give me one. Number 9, the product of two perfect squares is always a perfect square. Product. Okay, this one. Okay, this one is a perfect one to just punch into the calculator. Try a few. Okay, and then you'll see the pattern. Okay, it is true. Okay, number 10. If the area of a rectangle is how many weeks we got till Christmas? 3? 3?
Mr. Bennett, after
I can
today-
tell that for until Christmas break we want a seating chart. That's what I can tell.
After today, we only have 7 classes with us, which means we'll get a nice long break after only 7 more classes. But then we'll be here second half again.
That's true.
Yeah.
And then you'll have us even more.
Yeah, we'll go 9 weeks without a break.
That's okay.
No, we have.
Okay. This class is so strange. I'm like, we might have a seating chart, and they're just like, "Hey, Mr. Bennett, let's talk about something else." Okay. If the area of a rectangle is 6 meters squared, then the dimensions must be 2 meters by 3 meters. False. Okay. Also, I heard 1 times 6. Okay, that's the best example, easiest example. I wouldn't say best, easiest example to give. Okay, you could also just break it down into decimal numbers. Okay,
Times
something.
12.
Yeah, exactly. Okay. So, number 11, dividing by 2 always results in a number less than the original number.
Ball. Ball. Ball.
Odd numbers.
Ball. Negative.
False.
Can I move away from Connor?
Negative.
Hey, I'm really fucking good.
Connor, cover your mouth.
That Connor.
Yeah.
Mr. Bennett, we
Okay.
should not have our mask under our nose.
Who said that?
London. Hey, you should football time.
Everyone,
Football
time.
Always play with the random.
Everyone points at London.
Oh my god.
I know.
Come on. Okay. There we go. Okay. So dividing by 2 always results in a number less than the original number. That is false. Similar reasons as to number 8, right? Because you could have a negative number. Okay. You could also do 0 divided by 2 equals 0. Okay. Something like that. So number 12. Vertical angles are never complementary angles. It is false. The reason being, okay, if the vertical angles measure 45 degrees, then they are what? Are I will not be able to fit that word. There we go. Come on. Okay, number 13. If a times b equals 0, then either A equals 0 or B equals 0. What's up, Rocco?
If we're, well, we put a vertical angle with like, both of those being 45.
What do you think about 13?
Well, here's what I'm. What if,
I believe it is true.
yeah, because 0 times 0.
Yeah. How do you get 0 when multiplying? You have to be multiplying with 0, right? Okay. 14. Two angles supplementary to the same angle must be congruent. True. Number 15. All state names have at least 2 syllables. Kyler was talking about something else I told her earlier. Okay, number 15. False. Okay, Maine. Okay, number 16. Squaring a number and adding 1 will always result in an even number.
36. Yeah, 6 times 6 plus 1 is 37, which is not even.
Yes. Okay. So, your task, last thing on the notes, and I'll come around and pass out your, let's not think of it as homework. Let's think of it as an activity. Wasn't a joke. Okay. 17 and 18. Okay, you only need to do one of these. You're going to write your own conjecture. No. This is all reasoning and logic. Okay. Listen. Okay. On the last one on your notes, you're going to write your own conjecture. Okay. You are then going to give it to someone sitting next to you. They are going to determine if that is true or false. If it's false, then you give a counterexample. Let me follow that up with, does not have to be math-related conjecture. Okay?
They have to be smart ones or maybe really dumb.
Maybe really dumb.
Can we be really dumb with our conjectures?
Yes, as long as they're accurate.
Let's do this.
Or provable. That they are okay? Because they have to be able to determine if it's true or false.
Alphabetical order.
So not opinion.
Can we write the alphabet goes in alphabetical order?
Get your hand off my hand.
No. On American.
Yeah.
No, that's hard.
We have to do both.
You only have to do one.
Oh, right.
Okay, I got mine. There you go.
If you care about.
I can do it. I can do it. I can do it.
Wait, we can just try to.
That's a consonant. Connor doesn't know what a consonant is. I can't do anything.
What is that first word, Franklin?
I'm thinking about it, I don't know.
I have one that's pretty, that's like, you're in one of them, it's too hot.
I know. I just thinking about that.
We're not in America, so.
I know.
Oh my God, 5 times.
Oh, you're saying
He's like, you're like, you see this though? That's what he said.
But here, listen up. So I have passed out the first sheet of your homework. I have the second sheet right here. Okay, I'm going to save it. Okay, and this is going to be your bell work on Wednesday. Okay, so you only have one sheet. Okay, again, don't forget we will go over the study guiding class on Wednesday. You may or may not be having to take an eye station at the end of the week.
Whoa.
She gets
Cold.
she gets
He took my homework. I had school this morning.
Hey, Mr. Bennett, anybody in this classroom said anything wrong with that?
I would be very supportive.
You want me to fix that?
I don't know my rules.
I can't prove it. Thanks for the tough rejection.
Yeah, help with read. Not lot. If you don't help with read, like, add one.
3267.
Yeah, my parents, her parents are so fun and nice.
What is it?
Mine are like,
It's 4 prime numbers.
Bro, 8 times 10 is no. That's so funny.